Right, let's move on to data frames. Many of the aspects of working with series carry over into data frames. Now, pandas data frames allow us to easily manage our data with their intuitive structure. Like series, data frames can hold multiple types of data, but data frames are 2D, two-dimensional objects, unlike series. Each data frame has an index and a column attributes, which we will cover more in depth when we start actually playing with the object. The index attribute is just like the index of a series, though index in pandas can have some extra features that we will unfortunately not be able to cover here, but in future lectures. If you are interested, just check out the documentation itself. We can create a data frame by calling pandas.dataframe on a dictionary or NumPy array. We can also concatenate a group of pandas series into a data frame using pandas.concat. So we start with dictionary data. These are the keys A, B, C. These are the so-called values, and basically there are 5 values here. We are going to generate a normal random variables, random numbers, 5 of them here as well. If we print them up, A is this, C is this, and B is this. Now each data frame has a few key attributes that we need to keep in mind. The first of these is the index attribute. We can easily include an index of timestamp objects, just like we did with series. So pandas data frame, so we take the dictionary data, which is this one here, we create an index for them for 5 days, and we store that into frame data, and when we print it out, this is what it looks like. This is the data frame. As mentioned above, we can combine series into data frames. Concatenating the series like this will match elements up based on their corresponding index. As the following series do not have an index assigned, they each default to an integer index. So you have pandas series, pandas series, and then you concatenate these two series together. Basically, they are 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 2, 2, 1, 4, 3, even odds, and basically they just concatenate together. We will use pandas concat again later to combine multiple data frames into one. Each data frame also has a column attributes. This can either be assigned when we call pandas data frame, or they can be modified directly like the index. Now, when we print numbers column, you notice that earlier, this is evens, this is odd. It just print out the column attributes for you. To modify, we can actually change them by adding whatever this is. So basically we are equating this to this. So now it changed now. Okay, you have the even and odds has been replaced by these schmevens and schmoch. I'm not sure what Max is trying to get at there. In the same vein, the index of a data frame can be changed after the fact. So earlier, this part we're changing the columns, we are changing the index, and basically we're storing. Remember, the index of numbers is just numbers. Now we are trying to store date into it, and here you go, we have changed it into dates. Separate from the columns and index of a data frame, we can also directly access the values they contained by looking at the values attributes. Numbers dot values, this is looking at just purely the values itself. This return a NumPy array. How do we access the data frame elements? Okay, we can extract first of all this data from the Quantopian get pricing API. So we are looking at 4 stocks here. We're looking at 5 years of data. We provide the symbol and we print them out by doing it this way. Now, the symbol has been changed. Remember, the symbol that we were looking at earlier was very complicated. Equity, and then first the SID number, then the name. So what this function here really is actually just changing it to just symbol itself. Now, prices.cmg.head will give you the so-called first 5 values. Okay, and if we look at specifically want to extract just the CMG itself and the head itself, you will be able to extract exactly the same as this. So these are the 2 different ways to access individual columns. Now, to access an individual column will return a series regardless of how we actually get it. These 2 methods will give us pandas series exactly the same. Now, how do we pass a tuple into the log method? This is a key difference between accessing a series and accessing a data frame, grounded in the fact that a data frame has multiple dimensions. When you pass a 2D tuple into a data frame, the first element of the tuple is applied to the row, and the second is applied to the columns. So to break it down, the above line of code tells the data frame to return every single row of the column with the label CMG, and the list of columns are also supported. Okay, so row, which is everything, okay, and the columns is these two columns here. So we just want to extract the data of CMG as well as McDonald's. We can also simply access the data frame by index values using log. As with series, we want to look at this period here, and what you get is this period's so-called price data for all 4 stocks. Display nicely with list of columns too. Exactly the same. We're just looking at 2. Using ilog also works similarly, allowing you to access part of the data frame by integer index. So we're looking at 0 and 1, and basically for this is row, this is column, so looking at the second one. So the second one is MCD 01 because we're referring to 1 here. Okay, so here prices.ilog, we want to look at 1, 3, 5 plus the range from 7 to 100 and also 0 to 3, and look at the head only. So what you are looking here is that this is the row and this is the column. So we're looking at the 1, the 3, the 5, and then from the 7 onwards, and this is from 0, 1. Okay, 0 or 3, not 0, 1, 2, 3. Sorry, it should be, if it's column, then it's 0, 1, 2, but this is just comma, so we're looking at 0 and 3. Alright, so if we're looking at Boolean indexing as with series, sometimes we want to filter a data frame according to a set of criteria. We want to do this by indexing our data frames with Boolean values. So it's the prices where McDonald's is greater than the prices of WFM, and print the head of it. And this shows when the whole period when the prices of MCD is greater than WFM. So this period it is greater, but we're only accessing the head, so it really is only the top 5. We can also use the multiple Boolean conditions by using the logical operators and do this. Prices where McDonald's greater than WFM, and also if it's not equal to prices of Shaq is now. Basically, if it's now, okay, we want to remove it. Okay, and basically this is what happened. We extracted all of the data when SHAK is not a number. So this part here is true. Okay, and because we want it to be not true, right? So is it now? Yes. Not now means we want to select all of those with a number, and it's not a number. Okay, not a number, I mean. Okay, so basically here is when McDonald's is greater than WFM. Here is when SHAK is actually a number. Right, adding, removing columns, combining data frames and series. It is all well and good when you already have a data frame filled with data, but it's also important to be able to add to the data that you have. We'll add a new column simply by adding or assigning data to a column that does not already exist. Here we use .log, okay, the row and then the column name notation, and store the output of getPricing, which returns Panda series if we only pass one security there. This is the method that we would use to add a series to an existing data frame. Getting data of Tesla, and we want to add this into the existing price, and we want to print the head of it, so we just added Tesla to the existing data frame. It is also just as easy to remove a column, so we want to drop Tesla, axis is equal to 1, and there you go, it disappeared. So if we instead want to combine multiple data frames into one, we use the pandas.concat method. So this is to combine multiple data frame. we have two data frames. Data frame 1, which is SPY and VXX. Data frame 2 is Microsoft, Apple, and Google. And we want to concat them along the so-called columns. And this is what you actually receive. So you have SPY and VXX, and Microsoft, Apple, and Google here. All right, how to deal with missing data. So what you can do is fill it with 0, which is what we did here, or forward fill. Okay, forward filling. Sorry, this is backward filling. Again, basically the next really market price is 45.8, so we're back filling. But again, the best choice in this case to drop the not a number, and it drops all the rows where Shaq doesn't actually have a price at all. Right, let's perform some time series analysis with pandas. Using the built-in statistical methods for data frames, we can perform calculations on multiple multiple time series at once. The code to perform calculation on data frames here is almost exactly the same as the method used for series above. So don't worry about relearning everything. The plot method, exactly the same. So prices.plot, you get, should be 4. Yeah, there we go. The 4th one here, or I guess you can see the SHAK data is fairly recent. And the same statistical function from our interactions with series can be done likewise. We do a mean, x is to 0, meaning we want to look at the rows. Okay, we don't want to look at the columns. Okay, so when you actually calculate it here, and what you actually get is the mean return of these individual stocks itself. Sorry, this is not mean return, this is just the mean price, as well as the standard deviation, just by using STD to calculate the standard deviation of the price itself. Again, the describe function will provide us with the summary stats, like so. You just use prices.describe, and you can actually see these data. We can scale and add scalar to our data frames, as you might expect after dealing with series. This again works element-wise. So 2 times the price minus 50. Look at the head only, the top 5, and this is what you get. And we can also use percentage change method to get a data frame of the multiplicative return. So we take the prices, percentage change from the second data point onwards, because the first one is always not a number. And what you get is these are the actual returns itself. If we use our statistic methods to standardize the returns, a common procedure when examining data, then we can get a better idea of how they all move relative to one another. We take the returns minus the mean divided by the standard deviation, basically transforming it to the z-score, or how many standard deviation move, just looking at 2014 to 2015, and you plot it, and this is what you get here. This makes it easier to compare the motion of the different time series contained in our example. Rolling means and standard deviation can also work with data frame. So rolling mean of the price for 30, and if you plot the rolling mean, this is what you get in terms of the mean price. For a complete list of all the methods that are built into data frames, check out the documentation. So the next step is really managing data. Gets a whole lot easier when you are dealing with pandas, though this has been a very general introduction. There are many more tools within the package which you may discover while trying to get your data to do precisely what you want. If you would rather read more on the additional capabilities of pandas, just click on to this link. Once again, as always, thank you so much for listening and paying attention. I look forward to catching up with you in the next lesson.